Okay. 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 So that's good. So I'll show. I've already shown you that. I'll show you again. DVT Eclipse 1.1. Here you have to come and you have to browse UVM page not found. Okay, DVT Eclipse UVM 1.1. They might have migrated. Let us see. UVM package 1.1D is the most on functions. Okay, here control F UVM underscore TLM underscore FIFO is what we are discussing. Okay, come to UVM TLM FIFO and it will show you all the APIs and the constructor. And as I shown you, name, yes, we have given it a name. Next thing, we gave a parent as this, which is of the type of UVM component. Okay, UVM component parent. The third one is the size. As I said, the size is by default 1. You can override that. How? As I shown you, this declares a FIFO with a size of 5. Okay, for now we will keep it to 1. Now this is one part of the question. The next part of the question which says okay, here, okay, TLM FIFO, do we have to configure? Yes, we have to. The next one is, and I noticed no UVM phase. Yes, that is a very good question. Why? Because this connect and build are the phases from the very old UVM, that is UVM 1, not UVM 1.1 or something, UVM 1.0. The first version of UVM had phases which were called as UVM build and connect, not build underscore phase passing phases. Why? Because phase jumping, which we discussed last time, as I said you, when the reset is encountered, we want the entire test bench to go back to the reset phase, isn't that so? That phase jumping was not supported. That is the reason he did not have any argument. And since it is a backward compatible, we still support this, but I strongly recommend you don't use this. Use this new one, that is this. Okay, pass the argument of UVM phase to this guy. Okay, done that. Next thing what you have to do is make this as connect underscore phase. Save this. Okay, this I was explaining to the other batch. Thank God I missed to your batch. Now that you noticed, I got a chance to explain you guys what was wrong here. Okay, so using build and connect is deprecated. As a new users where we support phase jumping, we guys have to use build underscore phase and connect underscore phase and pass the argument as UVM phase UVM phase of phase. Okay, this is what it is. Any other doubts? Okay, no problem. Any other doubts, guys? No, then we have a very interesting discussion for today, that is no one remembers. What is the discussion for today? Sequencer driver communication. Okay, now there are three things in sequencer driver communication. Okay, what are those? Okay, first we will talk about a driver. Now when I say driver and I say that the driver has two interfaces, what do you conclude with that? Let me come here, open my pencil tool. That I say again, the driver has two interfaces. What are those two different types of interfaces that a driver supports? On the RHS side, driver has what? On the RHS side, the driver has an instance of virtual interface that is linking this driver, which is a class based environment, to the RTL, which is a static environment, isn't that? So what is virtual interface? What is the advantage of having a virtual interface, guys? Can anyone answer me that? We have gone through that question and answer 100 times. What is virtual sequencer? What is virtual interface? Sorry, I'm sorry. What is virtual interface? Why do we need it? What is the advantage of having a virtual interface? To connect the static world to the dynamic world. Yes, interface is static in nature. That's the reason we create a virtual interface, that is the pointer to the actual interface, and we will point through this interface and connect to the RTL from the class based world, that is the dynamic world. As I said you, the right answer it is virtual interface is a pointer to the actual interface. We need this pointer. Why? Because class based world is a dynamic world and static world we need to connect to. How will we connect from the dynamic world to the static world? Using the virtual interface, that is the pointer to the actual interface. Okay, now moving on. The other part here, what is this interface? What is this interface? This dialog here is my driver. Okay, this notepad here is my driver, which is the point of our discussion. Okay, here he has an interface which is the RTL connection using a virtual interface, and here one. What will this driver get from this part? He will get a transaction. Here, what will he do? He will do a pin level activity on the interface following the protocol. So if I say the driver has two interfaces, what are those two? One is the interface that is using the virtual interface to connect to the RTL. The other interface is linking him to the other class. What is the other class? The other class is sequencer. How is the communication between these two? Break in the line. Okay. So I am saying the driver has two interfaces. Two different sides of a driver has two different interfaces. What do I mean by that? I mean, driver on one side of it has an interface through which he gets a transaction or an object of a class. On the other side, he has an instance of virtual interface, that is the pointer to the actual interface, and following the protocol, he does a pin level activity on that interface. So on one side, object, on the other side, pin level activity. I concluded that the driver has these two interfaces or these two sides. You agree with me? One side of a driver, transaction level. So sequencer to driver, one side, transaction level. From driver to the interface, pin level. So don't you agree that these are the two sides of a driver, hence two different interfaces for the driver? You agree with me when I say that? Yes or no? Okay, so now this transaction is linked to the sequencer. Now, why we need a sequencer in the first place? We need a sequencer because if you think this driver to be a parking space, let's clear all of this. Let me draw a few lines and see you that. Okay, okay, one few more here and a few more here. Let's say this driver is a parking space. Okay, and there is a lot of traffic. That means there are so many cars coming in at the same time. There are so many cars coming in at the same time. Who do you see standing here? Who do you see standing here? We see always a guard standing at the entry of the car parking lot, and there will be only one input and one exit. don't you think? One entry and one exit. Can all of these cars enter into this parking lot at? No, they will not. They'll have to pass one by one. And who moderates it? Who takes care of it? Who controls this selection of one by one car? This guy might claim that I came in first. This guy might claim in that I came in first. But whose job it is to monitor and see who came in first and who gets to go through this lane first, followed by the next one, followed by the next one. It's this guard here, right? Is this police guard or the security guard, whatever you want, you can call it. So, who is this security guard in our verification environment? In our verification environment, this security guard is called as the sequencer. And what are these cars? These cars are nothing but transactions. Who gives all of these transactions? Test case. Test case populates all of these transactions to the driver at the same time or one after the other. Where he will do that? He will populate on the sequencer. Now it is sequencer's job to select one at a time and pass it to the driver so that if the driver can handle that transaction and do a pin level activity onto the interface. This is a brief intro into what is the role of the sequencer and what is the role of the driver. So in my terms, not in UVM terms or not in industry standard terms, in my terms, in my way of explaining thing, I always call the sequencer as a traffic police. Okay, so he's a cop. Who? What is his job? His job is to maintain the traffic. His job is to control the traffic flow to the driver. He is the one who selects one transaction at a time and gives to the driver. His job is not only restricted to giving transactions to the driver, but his job is also to collect the responses from the driver. Okay, and who gives all of these transactions? These transactions are given by the test case. How the test case gives it? One more object called as a sequence. We will get to that. But tell me, is this example clear? What is the job of the sequencer? What is a driver? How are they two connected? Sequencer, I repeat, traffic police. He moderates, he controls the traffic going to the driver. Why he need to control? Because at one time only one transaction can go to the driver. Whose job is it is to select the transaction? It is the job of the sequencer to select the transaction one at a time and give through this single lane to the driver. What does the driver do? The driver will take in that transaction, understand what do you mean. As I always, what is a transaction that goes from the user to the driver? Transaction is nothing but a set of inputs to the driver. What will the driver do using that transaction? He will understand what you want the driver to do using that transaction. Like in case of an ALU. We gave him A, B, C, and opcode. Using that, the driver understood, okay, now these are the values I need to feed into the ALU. So what the driver did? Immediately when you gave the transaction, the driver asserted enable signal saying that now I have a valid transaction from the user. I need to assert these values to the DUT. The DUT reads in those values. So the protocol will follow. Okay. So in brief, this is what a sequencer and a driver does. We will create the full-fledged example, but before we do that, is this clear, guys? Yes. Okay, so nice and slowly, no need to get confused. Okay, we will do one thing at a time. So where was that IMP declare example? Why don't I copy a few things so that we can save ourselves at some time? Okay, so let me just copy a few stuff here. Copy, come here. Okay, okay. One thing at a time. Language. Very well. So the first thing that we do is start a module. Stop. always import UVM package followed by UVM macros. Now what we are doing, we are creating a transaction extending from UVM object. Now here I want to pause and say there is a movie theater. One example, okay? There is a movie theater. You are in a queue. You are in a queue. If I say you are in a queue, don't you think there will be many people here standing and waiting in the queue? What are they doing? They are buying tickets for a movie. Okay, they are buying a ticket for a movie through this. Okay, now if I say there is a queue of people, okay, this all together, okay, let me use a different, this all together is a queue, isn't that? Who is this guy? This guy is a content of a queue. He is a human. He is a guy. Who is he? He is an item of within a queue. I'm here to bring out a difference. The queue and what is an item of a queue. You agree with me? If I say queue of people means all the four guys. Queue of people means all the four guys. Then if I say queue item, item means a single item within this queue. Who is that? This is a single guy. So queue item means this guy or this guy or this guy or this guy individually. But if I say queue of people means I'm targeting all the four people. Okay, in the same way we have two terms in UVM called as sequence and sequence means this queue which contains all the transactions, and sequence item means this individual item within a sequence. Understand the difference between sequence and sequence item? Okay, by mistake I cleared it. Okay, what am I saying? I am saying is that there is a queue, there is a queue of people or anything. Okay, queue. Let me draw a few very ugly looking humans here. I wouldn't call these humans some shapes. Okay, I don't know who decided that it's a shape of a human. This guy a bit tall like me. Okay, so we have these four people. Now all together if I want to address all of these four guys, what will I say? I will say it's a queue of people where one enters through like this and one exits like this. Okay, if I want to address all four of them at a same time, what will I say? I will say queue of people. If I want to address one single thing within this queue, what will I say? An item of a queue. Okay, or queue item or the content of a queue, isn't that? Content of a queue. In the same way in UVM we have two terms called as, this queue is called as sequence and the item or the content of the sequence is called as a sequence item. Now what is this sequence and what is this sequence item? Okay, coming back to the ALU example where we have a transaction. Now each transaction can mean an add transaction, opcode is add, or a subtract transaction where opcode is subtract. Or I can also create a sequence where add followed by subtract followed by add. So add is one transaction with opcode as add. Subtract is another transaction with opcode as subtract, then followed by add again. So if I club this add followed by subtract followed by add in one, what will it become? It will become a sequence. And individually this add, subtract and add are what? There are transactions, but they are within that sequence. They are within that sequence, so they become what? They become sequence items. They become what? They become sequence item. So whenever we create a transaction, we will extend from what UVM underscore sequence underscore item. If I create multiple objects of this guy and give it to a sequence, so these are nothing but items within a sequence. So we will not call it an object or transaction anymore, but UVM sequence item. And you guys are already aware that UVM object, and extending that we have UVM transaction, and again extending that we have UVM sequence item. And this is the childest class, okay, the last child class, okay, and that is the reason we extended from this guy. Always extend from UVM sequence item, okay. So we have UVM object class, extending that we have UVM transaction class, extending that you have UVM sequence item class, which is nothing but this class. So we always extend from this class. To repeat again, as I said, queue of people altogether is a sequence, in which, let's say this guy, how to give, this guy has a name A, B, C, D. The way in which these four walks is called as a sequence, and individually they are called as item of a sequence, okay. In the same way, if I change this order, they are now in an order A, B, C, D. I will change the order. I will change the order to be B, D, C, A. Now, this new order is called as a new sequence. Let's call this as sequence B. The first one was sequence A. Now, what happens? This is a new sequence wherein which these four guys are coupled in a different way. Their sequence is different. Okay, overall it's a sequence, but individually these guys are still items within a sequence. That is called as sequence item. Okay, so these are individual transactions. If we couple them in a way or in a sequence, we call that as a sequence. We'll get to sequence later, but we are still here. A single transaction is called as a UVM sequence item. That is the reason we extend it from UVM sequence item. Okay, is it clear? Things will be clear slowly. Okay, is it clear, guys? Two things, UVM sequence item and UVM sequence. Okay, loud and clear. Okay, everyone can hear me. Sridhar can re-log in. So by the time he re-logs in, who got dropped off? Ningho, Naru. Two people got dropped off. Okay, why is that you people are getting dropped off? No, no, God, I'm able to hear you now. China. Some problem with your internet, guys? All of you using the same internet? Because I see all of you are having a problem today. Okay, so Oh, Hyderabad network, right? Beam cable. I know, I know. Optical fiber they provide. Okay. So I understand, I understand. No problem. We will use it. We'll do. Okay, before doing a save as, we have come here. So we have our transaction ready. Now what to create? We have to create our sequencer. Sequencer is the traffic police. Now tell me, every traffic police that you see, do you train him? You see a lot of traffic polices everywhere. All you do is you and you see them controlling the traffic, and they know how to control the traffic. Do you train them? No, they are already trained. In the same way, I know my examples are lame, but I have to. I don't know why, but I have to give you such lame examples. Why? Because at least in a very, way of humor, you guys would remember how things work here. So let us create one. Let us let us create one. What do you say? Traffic police guy, and call it as my sequencer. And I stated, as I've already stated you. Do you train this guy? No, you already get one, an already trained one. Why I said? Because when you extend your sequencer from UVM sequencer, this UVM sequencer is already trained, knows what to do. All the good logic, all the handling logic is already implemented there. All you have to do is make use of it. All you have to do is hire one traffic police for your verification environment, and you have to say whom he has to manage, whether he has to manage cars, whether he has to manage motorcycles, or he has to manage the people. In this case, he has to manage transactions of type this class. So his type parameterize, give him that end class, and then since it's a component in the verification environment, we'll register to the factory saying UVM component underscore utils, then give my underscore seqr. For components we need constructor with two arguments. So we have one constructor with one argument for the object. We can copy that, no problem there. Do a bit of editing and we are done. Okay, so give it two spaces. Replace this with my underscore seqr. Then say comma uvm underscore. What should I write here? Guys, what are the two changes that I have to do? Forgot? UVM parent. Why? Because components have hierarchy. We need the second argument, comma parent. Okay, so now we have our sequencer ready. As I said, we hired one. How? We extended from that guy. This guy is complete. This guy is 100. We have to only hire this guy, give him a new name, and say him what he has to handle, and he will handle everything for us. Okay, we don't need to do anything. So we know what a transaction object is. Okay, with three fields, that is fine. Now we have already hired a traffic police guy. Now what we need? We need is a driver. Okay, let's go ahead and create one. Class my underscore driver. Again extends from what? Driver is a component. Should I give it the name UVM component? Should I extend from UVM component? No, I should not. That arbitration logic is already coded in UVM sequencer. Yes, I understand. And that is what I'm saying, right? Basic arbitration logic is given to this UVM sequencer. And if you find that you need to prioritize the traffic which goes into the driver, you will learn that. Then you can change this arbitration logic. You can give priority to things. You can pause the sequencer. You can resume the sequencer. There are many functionalities. We'll discover one by one. Okay. For, and for now, we are targeting only the basic stuff which gets the job done. Okay. So that basic arbitration, how to select a particular transaction one at a time and grant it to the driver, this UVM sequencer as is can do it for us. Okay. So basic internal communication with the sequencer is already well coded for you. Okay. Let's think this. I have to stop. Share the screen again. Can you guys see my screen?
No, you logged out from the live meeting.
Okay, can you guys hear me and see my screen? It says since sharing well. Okay, you can hear me? Okay, can you see the screen? Okay, that's good. Because it says screen sharing stopped, so I have to refresh it. Okay, so now we are creating our own driver class. My driver extends UVM driver. Now there are only three classes which are type parameterized in UVM. Those three classes are sequencer. Why? Because we have to tell him that what type of a transactions or what type of a traffic he has to moderate. Okay, first thing, driver. Why is the driver parameterized? Because the driver has two interfaces. One is the virtual interface, which we will declare and we will handle. The next interface is the communication to the sequencer. Isn't that? So the communication to the sequencer, that part we have to say what type of communication he has to establish with the sequencer. So that is the reason our UVM sequencer class is parameterized, UVM driver is parameterized, so is UVM sequence. First we will code the driver. End class. Driver is a component. So we can copy these two registry as well as the constructor thing. Okay. So here we can replace this with my underscore driver. Say this as my underscore driver. Okay, done. Okay, class my driver extends UVM driver. Now here you have to understand one thing, how sequencer and driver are connected. We have a knowledge on TLM, isn't that? We know put port, we know get port, we know analysis port, we also know TLM port. Now it's time to learn one more. What if we come back, sorry, not come back, go back and analyze what we have learned in TLM. We have learned in TLM that we have two modes, that is push mode and pull mode. In both of these two modes, the data flow remains the same, only the control flow changes. You agree with me? Control flow means input mode, who is the initiator? Input mode, producer is the initiator. So the control flow is from producer to consumer, and so is the data flow. The data flow is always constant. It is always from producer to consumer. There is no change, and it is not bi-directional. The data flow is not bidirectional. You agree with me? You can only give data from producer to consumer, but you cannot get data from consumer back to the producer. Now that is a problem for me. Why? Because the nature of my environment will always be, I give a request, I need to expect a response based upon that request. Isn't that? Now you guys have learned, to give you an example, you guys are aware of APB protocol. In this APB protocol, you asserted enable, okay? You asserted select, you asserted enable, you gave one transaction address and data. To that, the slave has to respond with HRD saying that, okay, I latched this one and it is correct for me. So that is a response, right? Response saying that, okay, the transaction is done, the transaction is successful. In the higher level of protocols, there will be ACK mechanism saying that this following current transaction, should I acknowledge it or should I say not acknowledgement with an error? So all of the times you see that there is a response coming back. There is a request and response mechanism. So in the same way, you give a request to the driver. The driver will follow the protocol and transfer that request using the protocol to the IP. The IP will respond back. The IP will respond back. That response you have to again latch and understand what was the response, whether the response was okay or did it end up in an error. So how to give this response back using put and get? You cannot do that. That is the reason there is one more new type of port which is called as pull push mode. Why? Because it has both pull and push mode combined into one, where you can all give the request and you can collect back the response. That new ports are called as sequence item port, which is already instantiated on UVM driver. Since you are extending our driver from the UVM driver, you inherit that. So what is the name of the port that is created on UVM? The name of the port is sequence seq underscore item, meaning that we get sequence item from this port. Sequence item port. In the same way, as I said, sequencer is also well coded for you. The sequencer also has port. What is the name of this port that a sequencer has? The sequencer has a port. This port name is again sequence item underscore export. Only change. Okay, so they are already coded, they are instantiated. Since you are inheriting from these two classes, you will get that. All you have to do is make use of it. Just like I always say, UVM is a framework. That is, the basic framework is already done. All you have to do is extend from that and provide your user specific implementation. The basic framework of ports, connections, sorry, ports, instantiations, port logic, arbitration logic, all of that is already done. Okay, so no, two new things. UVM sequencer are one single component, UVM driver one single component. UVM sequencer has sequence item export, UVM driver has sequence item port. So we will connect these two ports together to get the job done. Okay, we will connect these two ports together. What two ports? Sequence item port and export. What are these? What is the mode? You will ask me. You have been eating my head all day long saying pull mode, push mode, producer, consumer, control flow, data flow. Where does that fit in into this one? So that is the reason I said these are the new special type of ports called as pull push mode, which has both pull mode and push mode combined into a single one. Hence both the bidirectional control flow and bidirectional data flow. Okay, why? Because again I quoted you an example saying that always will we encounter an IP on giving a request, it will respond back with a response. So you have to handle both the request and the response. That means we need a bidirectional flow of data where one direction carries me a request, the response is in the opposite direction. That is the reason we have these two ports, sequence item export on the sequencer and a sequence item port on the driver. Is it clear, guys? Now we will learn how to use this APIs present in these two ports. What are the APIs that we learned so far? That we will cover first. For that, we have to come to task run underscore phase UVM underscore phase of phase and task. We will create transaction request response. Okay, so here we can come down here and say, now as I said, we have learned two things: push mode. Okay, before push mode we have learned something called as pull mode. Pull mode means what port, guys? Pull mode is get underscore port. What is the API used? Get. In push mode, what is the API? What is the port? Put underscore port. What is the API? Put. Okay, now we have both pull and push. Okay, let us see. Pull, push. I will write as a comment here. Pull the request first based on the request, drive the data on the interface. What is the last job to do? Use push to push the response back. Okay, now to make things interesting, we will come up here. Okay, and we will create a enum. Type def enum. We will call it as ACK. We will call it as a NAC. And we will say resp underscore e. As a nice practice, underscore e means it's an enum. Okay, come down here. Oops, what did I do? Okay, come up here, and for all of these guys, what we will say, rand resp underscore e, and I will say resp as in response. So how do I register this to the factory, guys? Can you help me with that? What is the macro that I should use? UVM field, then enum, then I have to say what? Resp comma, no, resp underscore e with enum 3 arguments. Never forget that. Resp underscore e, that is the type of the enum. Then the variable using that enum. Then UVM underscore all underscore on. Okay, then come down here and say, what is the first step? Pull the request first. How to pull the request? We know that we have sequence item underscore port. To pull the request, we have to use the API called as get. Okay, we'll say dot get. Get what? A request. Okay, we will get a request. Then what to do? Drive, based on the request, drive the data on the interface. For now, in this example, we don't have the interface. What we can do? Consume the request. To consume the request, what we will do is we'll only print it. Take UVM info get underscore name comma got the request, and use $ps printf $ps. I have already shown you guys how to use $ps printf. I've already shown you how to use percentile s with request.sprint. Isn't that? You guys forgot? Want me to repeat? Yes or no? Okay, so here we can say UVM underscore low. Okay, now we are done. So I'm trying my best to keep it in a single thing. Okay, now after that, push the response back. To push the response back, what we have to do? We have to only update the response. Request dot RSP equal to act. Okay, RSP equal to act. Then to push the response back, what we have to use? We know the API, right? We know the API. Sequence underscore item underscore port dot put. Put what? RSP. Now here we don't have a API called as put. We have, but we have to use an API called as put response. Makes more sense, right? Put response. Put response how? Using this. Now here instead of get, we have something called as get underscore next underscore item. Okay, a small change in API. Okay, we need a tier. No, we don't need it. We don't need it. Okay, why? Because I'll get to that. We don't need it. So a small change. Instead of get, we have get next item. Then we have to put a response. We need put underscore response. But as I said, giving a response back is optional. Few things will have a response, few things will not. So to do take care of that, we have is sequence underscore item underscore port dot item underscore done, followed by that put response, which is optional. Okay, so this is compulsory. You get a transaction, you consume the transaction, and then you say I am done consuming the transaction. Then in the second step you say I also have a response accompanying that. If your API or if your DUT, if your IP does not have a response, this step will be optional for you. Okay, this step will be optional for you, but these two steps are compulsory. Pulling a request, consuming the request, and saying I am done with the request, I need one more. So how long do you want to continue getting the request and responses? Forever, right? So for that, what we will do is we will use forever begin end. Okay, forever begin end. Forever first step, pull the request, consume the request, update the response, then say I'm done with the request. Response is still pending. Why? Because it may happen that it's a pipeline protocol. It may also happen that you get a request, you give that to the IP, you might get a response after 10 cycles. Like in case of AXI, I don't know if any one of you knows it. AXI, what happens? You give a request, you'll not get a response now. You might get a response now, or you might get a response after 3 different responses. So it is an out of order response mechanism to support all that you have. So, okay, sorry, I will, as a clean
Request and
approach.
response is bit. Hello? Hi?
I couldn't hear what you
Hi,
said. Your voice got, your your voice is breaking, buddy. I cannot hear. Can you please, if it's convenient for you, type it down? Can anyone else hear what did he say? His voice was breaking a lot. Ravi, is it? Is the request response between sequencer and driver? It is between sequencer and driver, but yes, it is between sequencer and driver for now. But overall, it is between the sequence and the driver. Sequencer is just a guy who is managing it, right? No. This request and response is between the sequencer and driver. Sequencer and driver. Sequencer and driver. We are not talking to the DUT here.
But here you put the response. Who will give the response? It's a sequencer will give the response.
Okay, see here we are pulling the request from whom?
Driver.
Sequencer. Pull the request into the driver from the sequencer. We are in the driver, right? We are in the driver. So
Yeah.
with get next item, what we will do, we will pull the request into the driver from the sequencer. Based upon the request, what we will do, we will drive it onto the interface. Okay, then we will say to whom, say to, I will write it down, communicate to the sequencer that you are done with the request driving on the interface, that is dot. Okay, you are communicating to whom with this? Again, to the sequencer. Sequence item port means sequencer communication. Communicate to the sequencer that you need one more request, consume the request, then communicate to the sequencer that you are done with the request, saying that I am done driving, sorry, I am done. Then next, push the response back to the sequencer based on the response given by the dot. So this or nag, this ack or nag will be given by the dot. So you take it and then give it to this item and give it back to the sequencer. Is it clear now? So this getting an act is again based upon the dot only. So now why did I break this up into this one? Because you might have pipeline things, you might have a protocol wherein which you give a request, now you'll get a response a lot later. So you can say that I'm done. Here with the item done, you can say that okay, I'm done, I have driven the request, but the response I haven't got from the driver yet, so I'm waiting for it. So wait for it, latch the response and give it back. Okay, three steps, three APIs we have learned today. Get next item, what does get next item do?
It will
What
fetch
does
the
get
data
next
from
time?
sequence.
Yes, from the
Fetch the
sequence.
data.
Yes, you are correct. But for now, we haven't learned sequence. Now we will say that as sequencer. Okay, fetch the request from the sequencer. What does item done do? What is the item done's job? Item done will say, I'm done using the request. What is put response do? Put response will say, okay, I got the response now. Take the response. Get, put, coupled both in a single port. Now you see you are using get as well as put. So that is the reason it is called as pull push mode. What is the new port that we have learned today? The name given to him is sequence item port on the driver. What is the name on the sequencer? Sequence item export. Who is a sequencer? Sequencer is the traffic police. Do we need to train him? No, we don't. What I mean by that, I mean you need not provide any implementation in the sequencer. What is the code of the sequencer look like? All you have to do is extend from the UVM sequencer, that's it, and register to the factory. Apart from that, you need not do anything else. In driver, two more important points. UVM sequencer and UVM driver are parameterized with the type of the transaction that you are running. Extend from the UVM driver, register to the factory. In run phase, have a forever. Why? Because you have to run forever. As long as the test case is giving you transactions, for that long you have to drive those transactions, isn't it? So what you will do forever. How to fetch a request from the police? How to fetch a request from the sequencer? Using get next item. Say, give me the next item you have. You take the item, you consume the item, and you say, I am. Then what you do? You come down, you wait for the response. If you have a response, then you say, okay, now I am putting the response. For now, we will comment this response mechanism. Why? Because it will confuse you. We will learn that. First thing that we will learn is how to take a request and say, everyone else, can you hear me? Yes. Now, see what is the problem at your end. Everyone is attending, right? Yes. Okay. Okay. So far clear, guys. So can anyone summarize me what all we have? It is initial value. It's a handle, right? No. It will be ACK. Why it will be ACK? Initial value will be ACK. Why? Because the default value will be the first value, right? It's an enum. Initial value will be ACK. What we can do is we will learn this. All I wanted to do was randomize this so that at one time you get ACK, the other time you get NACK. We will do that. We'll do this response later. First, we will learn how to get a request and say I'm done with the request. Then we will say how to wait for the response. Why? Because there are not just one, two to three different ways of giving the response back. And there is also put and get without an item done. It's very confusing. So first we will get next item and item done. Yes, you're correct. You're correct. You're 100% correct. Okay. Okay. So, can anyone summarize me in a comment, or you can unmute yourself and tell me what all we have learned so far in today's discussion? What all we have learned so far in UVM is one side. The discussions from today are on the other side. So this side is pretty heavy. Those are basics. This is what you from today's class. These are what you do on a daily basis in UVM. So can anyone summarize me quickly? We are running out of time. Mechanism of sequencer driver communication. Yes, the two driver interfaces. What are those two? On one side you have transaction level interface, on the other side you have the virtual interface. Yes, you are correct. What is the new port that we learned today? What is the name given to him? We also learned, yes, difference between sequence item, sequencer, and sequence. Okay, intro to sequence item and sequencer. Yes, what is the port name on the sequence item port and export? Yes, sequence item port is present on driver, sequence item export is present on sequencer. Okay, what are the three APIs that we learned in sequence item port? The three APIs are get next item, item done, and put response. What does get next item do? It fetches a request. What does item done do? It says that I'm done with the request. What does put response do? It will put a response back to the sequencer. What is the job of the sequencer? Sequencer's job is to arbitrate. He is an arbiter. He is a traffic police. He moderates all the traffic. Now we have learned all of these things. Now where is the traffic? We have seen that traffic, taking one request at a time from the traffic, giving back the responses. Then where the hell is this traffic? This traffic will get populated tomorrow. Tomorrow we will create sequence. All of these traffic will come from the sequence. In sequence also we have few interesting macros to learn. We will learn there are few breakup of those macros into different APIs. We will cover that as well. Okay, and I might need 2 more days, that is tomorrow and Monday, to cover this sequencer driver communication. I don't know if been practicing the examples, but I request you, this example you have to practice. go back, look at it 100 times. Why? Because when you come tomorrow, you'll forget and things will take a different turn. Okay, so I'm done for today's class, guys. You have any questions for me, please ask me. If not, we'll put an end to this discussion. Let's say save as.